All right, thank you very much. Welcome back to this video. In this video, I'm going to do a comprehensive explanation of how to wire a complete solar protective kit, both for the DC side and for the AC side, for your solar system protection to get ultimate protection, especially your hybrid inverters. Now, for this case, I'm going to be talking about inverters that have dual MPPT for the DC side. So you can see from the box, you can see that we have two DC breakers, then we have two DC surge protective devices. So one side of this connection, the breaker and the SPD, is for string 1. Then the other side is for string 2 of the other MPPT. So I expect to connect 6 panels to this one, then 6 panels to this one as well. So this is the DC box. So when you have this kind of setup, it's best for you to separate the breakers for each box. So you get the box for the DC breakers and SPD, then you get its separate box for the AC breakers and SPD and every other accessory that you need to add to the setup depending on how you do yours. Okay, so but for this time around, most times I normally use a changeover switch, a manual changeover switch for my AC side, but this time around I've incorporated a breaker changeover. So I'm also going to show you how to wire this breaker changeover. All right. Then you can see on the AC side, we have the AC SPD. We have the AC input AVS. So this AVS, it checks the voltage or the current that comes from the input to the inverter from the grid or the generator. Then this is the AC breaker. All right. Then from the AC breaker, we have this device. This device is a check meter. It tells you the amount of power, energy, current that you consume at every given time on the load side. Yeah, it is connected to the inverter load output wire. So you can use this to measure the current in real time, measure the voltage, the kilowatt hour, the power, and everything that it has consumed over some given amount of time. So it retains the information. Yeah, even if there's power outage or the inverter goes off. So when you switch it on, it continues from the previous values and starts to count again. So it's very important for especially installers that want to do some calculations and to know the amount of energy that they've been able to save over a given period of time using their inverter. So it's connected to the output side of the inverter. So because I'm only going to measure the output side, yeah, not the input from the generator or the grid supply. Then we have the changeover breakers up, down. So middle is neutral, down can either be solar or grid or generator. Then we have the output AVS. So this one, you can use this to control the amount of load that is being used on the output side, yeah, of your inverter. So you can set the maximum current that you want your inverter to dissipate. If it goes above that maximum current or voltage, you're going to shut down. That's the essence of this. So this is a complete solar protection box. It's not cheap. So if you have to do something like this for any of your installations, make sure you take your time to calculate the cost for each of these items and incorporate it into your quotation properly, so you don't end up running a task scatter. Everything here costs more than 200k, 200 to 250k. So in case you want something like that, I can also design it for you if you don't have the time to do yours. So it's very, very handy when you take this onto site and it's already prepared. All you need to do is just to fixing your input from the PV, fixing your input from the grid, then fixing your output from the changeover breaker to the DB. So let's go over some tips on how to wire it. We've talked about this before in our previous videos. I just want to do a recap. Normally for a DC breaker, what happens? Input goes into the DC breaker. Yeah, from the PV. These are your panels. So we have the panels like this. So let's assume that this is the entire panels that have been connected. Then the output comes like this. Now the first thing, the output goes to the DC breaker. So which is here, this one here. So when it connects to the DC breaker, then DC breaker, we have the top part and the bottom part. So this is the top part. This is the bottom part. From the bottom part is the output, then the top part is the input. This is a bidirectional breaker. So This one can be input, this one can be output, this one can be output, this one can be input. It is not specified that you must use this top side as the input or output. So it based on your preference, how you want to connect it. That will determine where you put your input and output. Some persons like to pass it through the bottom part, the input here, so they take output and loop to the SPD. You get your input here, then loop to the SPD. At this point, you have to loop to a different device here, which is the SPD. So this is how it works. So positive loops to positive, the negative loops to negative. This is negative. Okay, so your DC breaker, your SPD. So for one string of the panel, that's it. There's a lot of arguments about how to connect your DC and SPD combination combo. Now, some persons say it's best to connect your SPD from the output of the DC breaker. For instance, if this is your output, you connect the output to your load or to the inverter. Then you also, from this output, connect to the SPD. While others say no, you have to connect the SPD from the input side. So it depends on you. Whichever one you want to use, you can use it. But me, I have been using this method. I connect the SPD to the input side. It has been working perfectly for me. So I will just continue with that setup. So you can see I've already crimped the cables the way I want them to be. So I'm just going to screw them inside and make them fit in perfectly, right? So when I do that, that'll be all for the DC box. Then you can see the earthing, the earth cables already. I've also crimped them. Yeah, with I have fails. Yeah, a lot of them right here with me. Connectors and all that. Then we have my crimping tool. Yeah, I have a lot of tools, yeah, that we use for work. So I've done everything, and it's just a matter of plug and play. So I'm here with my screwdriver to just screw in all of these terminals inside, so we can proceed to the next step. So let's wire up this DC side. So you can see that the earth cables have been connected. So to this bar, it's best to connect the individual earth cables to a bus bar or to an earth bar, not to loop from one to the other. If you loop from one to the other, it kind of creates some sort of resistance, and when it's supposed to be active, you tend to get some current sharing, some goes to the ground and some locks around the entire system to cause some sort of disarray in the system, and can also affect the functionality of the system in total entirely. So let's just hook it up, connect the earth cable on this side, then on the other side is well connected, then here as well connect it. Then this one is the general earth. Okay, I will not connect this one really. Let me connect this one. So it has been connected, and so this is the general earth cable that links both SPD earthings to the ground. That's settled. Then connect also these ones too. Ensure it's tight. Okay, I've already connected that of the DC. So we have the inputs from the PV. It will loop into this port. Yeah, plus or minus. PV1 will loop into this side. PV2 will loop into this side. Then the output from here goes to the input of the inverter. Then we have the SPDs for the DC side. Then the earth cable. So I'm just going to grab this one and keep it aside. So we are done with this. Then next, let's talk about the AC. This is looking a bit complex, so I'm going to dissect everything we are seeing here, so we get to know how it's being connected. So I'm just going to draw a small diagram that represents all the connections that have been done inside of this place. Okay, so let me do the diagram now. First of all, we have the ACSPD right here. This is the ACSPD, SPD. All right. Then we have the AVS input AVS. Then from there we have the AC breaker, the 63 amps breaker, AC breaker. Then we have the meter, the power meter, Then from there we have the breaker changeover or the changeover switch. Anyone changeover. From changeover we have the output AVS. AVS. So I'm going to show you the sequence. First of all, you do your normal connection for your AC. Now you can decide to use either the bottom or the top as your input because it's a bi-directional breaker. Now the inputs, I've decided to use the bottom as input, yeah, for this one. So you can see the input side of the AC breaker is empty. I'm going to connect the input from the grid or the generator, yeah, into this side. So I've also done the earthing. Let me just hook up the earthing for the AC side first of all. So connect it to the earth bar here. So let me do that one first of all. Settled. We have the SPD, AVS, AC breaker. So I've decided to use the bottom part as my input. Then if you use this as your input, then what happens? So if input goes into this side, then the output from here loops to your AVS, right? So positive to positive, negative to negative. So it loops to your AVS. Then from your AVS, it also loops to your SPD. So you take another one from here, take it to the SPD. Also loops to your SPD. So that's exactly what I've done here. If you check it properly, you see that AC breaker to the AVS, then from the AVS to the SPD, life and neutral, following the polarity. Then from there, this one goes to the earth. The SPD is earthed, as I've demonstrated here already. It has been earthed, connected to the earth bar. Then we have output here. This output is what goes into the input of your inverter. So we have your inverter at this point, inverter inputs. So it goes into the input to charge the battery, whatever battery you use, through the inverter. All right, the inverter has a good charging support. Okay, then that's for that. Then the second part, for this AC side, we have it is separated into two parts. We have the input parts and the output part. So this part is the output. Let me just O and P. This part is input. For the output side, we have the check meter. It's not necessary to use it. This is a changeover switch. It's necessary. This one is also not necessary. All right. So I just want to add everything together in case you need something that is robust. You can even add a breaker, yeah, output breaker. So if you have more load, you add more breakers. All right. You can even create a separate bus for breakers and separation and all that. But that one is a story for another day. Then from this output side, what happens? What's going on here? We have the breaker changeover. The breaker changeover has 6 ports. Of course, 1, 2, 3, 4, 5, 6. Then the AVS, 1, 2, 3, 4. Then the meter, like this. Then it has a line inside, a hole inside. Now, let me tell you how it's connected. First of all, we are going to connect the output of our inverter to the changeover switch right here. So forget about the breaker. Just let me show you how it works. If you check this changeover breaker, you see we have two inputs right here, the one output. It's just like a normal changeover. Normal changeover is like this, something like this. We have this. So we have the input one up, one down, then the output at the middle. But this one, the only difference is that both inputs are at the bottom, then we have the outputs on top. So you can take this one up, then center is neutral, then down it's the other power source. So up is the first power source. So I really don't know for certain which of them. So you can see the numbering. We have 2 and 6. So 2, 6 represents the source 1. Then y 4, 8 represents source 2. You can see properly, right? Then the output is 1, 5. This output is what goes into your dB. All right, it goes to the dB. Then the input from here, the one that goes into any of these one, let's use the bottom part, which is the 2.6 as inverter input. So you connect the inverter input, the inverter supply from the output of this AVS, because normally you are connecting the output of the inverter to the input of this AVS. The inverter's output comes here first. Then from here, you connect to one part of the changeover switch already, the inverter part. All right. Then from there, what happens? Before you connect the AVS to the inverter changeover, you need to pass one of these cables, either the positive or the negative, through this power meter, because it has a hole inside that is used for measuring current. So you can pass either the negative or positive. So I decided to pass the negative. So before it goes into the changeover, before this one goes into the changeover, it's going to pass through the meter in this manner. So when it comes around like this, it then connects to the changeover breaker at this point. So that's what's going on here. So you can see from here, it's going around inside the meter. Then it gets to this point where you connect to the output of this AVS. Okay, then the other positive connects directly. So we have the inverter side, the inverter output on this changeover breaker already. That's how everything here is connected. Okay, so it's not rocket science. So I'm also going to demonstrate it with a live inverter and a battery, small battery setup, so that you see what exactly is going on. All right. Then this small stuff here um, is a CT, current transformer. It's used for measuring current above 200 amps, 250 amps. But if it's just low current, small current, between 10, 20, 30, 50, these hole right here can measure the current. All right. So for you to be able to power up this meter, you also need to connect from the same source that you want to measure the current. So you connect it to this side. So the 2.6. All right. Also connect to 2.6 as a power source to the meter. Okay. So everything here is properly connected. All I'm going to do now is to use my screwdriver to hit the screws inside so they are firmly connected. Then I will demonstrate with an inverter and a battery to see how all of these things work as one. Thank you. Okay, so let me just connect them firmly. Then negative here. We'll loop this one. This one is looped, connecting two. So you have to be very careful. All right, then, so we are okay with this now. The next video you see, it's a video of a small inverter and battery setup. So we can just do the connection, yeah, as much as we can. So to buttress the points I've been trying to make, yeah, about how to connect all these things together. The input side, this is the input side, this is the output side. Just to recap, we have the input AC breaker, then we have the AVS, so the input, then we have the ACSPD. Then this side we have the check meter, power meter, and all that. Then we have the changeover breaker. Then we have the output AVS. Yeah. So the changeover breaker enables you to connect the inverter and also your grid input inside the enclosure box. Now you're going to take this down to the DB. Yeah. You hook it up, the neutral connects to the neutral bar, then the live wire connects to the where you had the existing live before. Then the one you remove from there, that's the output of the former changeover, is where you're going to connect as the other source on this changeover breaker, which is on 4 and 8. You're going to connect to 4 and 8 on this side. So that one there, I cannot demonstrate that one now because there's nothing like that here. Then this one, we have the power meter. You have to power it on so it can check the power, voltage, current, a lot of values, yeah, that your inverter is consuming at every point in time. Okay, this is the entire setup I was talking about. This is a small inverter, a 1 kV inverter. Then we have a small battery that we can use for this test. It's going to take up to 10 minutes, all right? Then this is the extension we are going to get our input from, the input source. So from this input, we'll take input to the input breaker. So this is it. You can trace the wire to the input breaker here. So when we turn on this breaker, the breaker feeds the AVS. So when it feeds the AVS, the input side, then the output side connects straight to the inverter's input wire. This is the inverter's input wire. So you can trace it with me. So this is it. It goes there. So when input goes into this inverter, it activates the grid charging to the battery. So it starts to charge the battery. All right. Then you can set the voltage, the over voltage level, the over current level, and everything on this AVS. When you do all of that settings, the input side has been taken care of. Then let's move to the output side. How does power or current flow from the output of the inverter to all these other devices? This is the output side. Output wire goes straight to where the input of this AVS right here. This is the output AVS. So when this one goes into the check meter, then passes through everything, then it goes into the breaker, chamber breaker, one side of the chamber breaker. So we can either chamber to down or to the top. I think it's the bottom one. So it gives output to this extension. So we are going to plug our output load. So we're going to use this fan. There's a fan here. So using the fan, we're going to see the current, the voltage, the power, and every other thing we need to see. Then before that, we are also going to have to set this AVS, the absolute AVS, to make sure the voltage is not too much and all that. So you know what to do. So let me turn on the breaker so we see what's going on. First of all, I'll turn on the inverter right here. So the inverter is on. So you can see it's already supplying output to this AVS. I did the settings on this AVS to come on after 50 seconds, or I think 1 minute, 60 seconds. So when it counts down from 60 to 1 or to 0, it's going to come on. So it's supply output to this load. All right. So let's see. Okay, it's on now. So we can see the voltage is 221 volts. So at this point, the load has not supplied anything to this extension yet. So let's take it to this other side. Everything is powered up right now. You can see it has counted down to 0. So we have 222 volts. So let me turn on this check meter and see the voltage on the meter. 222.5. Pretty much okay. So the chamber switch is on this side. Yeah, the bottom side gives output for 2 and 6. Alright, let me connect a load, my fan, so I'll see the current. So the fan is on, so 0.5 amps. That's the current I'm consuming right now. Voltage has dropped to 224. So everything is fine, working well. So I'm going to set this stuff to trip off at 0.5. I'm going to set the peak current to be 0.5. So if I add another thing to it, it's going to trip off. So let's see. Let's set it first of all. So it has gotten back to 0. So let me set. So you go to settings. That's settings 9. So I'm going to reduce it to 0.5. So when I connect the fan, it's supposed to work. But if I add another loads to it, it's going to trip off. So let's demonstrate that to see if it actually works as stated. Okay, the minimum current is 1 amp. Okay, let me set it at 1 amp. So connect this on 0.5 amps. So I need to connect something else to it so that it can trip off. So I'm going to connect my laptop charger to it. Has gone off. So it's not 0 because anything that makes the current to be above 0.5 is going to trip off. So when I move the laptop charger, it's going to reboot after some seconds, then it will supply current again. All right. So that's how this stuff works. So that's why this stuff is very important. Yeah. To protect your inverter in case your inverter is not a big one. I have big loads, heavy loads. So you know the peak current of the regular loads you normally use. Then you set the current to with maybe a little bit of tolerance or +3 to +5 tolerance. Yeah, so if it increases above that level, it's going to help you turn off the inverter. So let's check the input side. So I'm going to turn on this breaker. We have the input source already from this side. It's a different source. Don't be scared. So when I turn on this one, I'll set this device. So let me turn on this one now. So this one, it counts down to one. It's going to charge. So the inverter is charging right now. So everything is complete and correct. So we have our AC surge. We have so it's charging at 1.6 amps. So we have the input AVS, the AC breaker. We have the check meter for your load to see the amount of power that you've been able to consume from your solar setup. Then we have the changeover breaker. Then we have the output AVS. So everything is well connected. Everything is working fine and good. So this is one of the best ways to connect to solar protected devices. Don't forget your DC box as well. It's also here. Yeah, it's straightforward. Just connect your PV input here, then the output to the inverter or the charge controller. So that was all for today, and I know you've learned a lot from this video. Please make sure you hit the subscribe button, hit the like button, and if you have any question, put in the comment section. So let's brainstorm about it. Let's learn, and so let's see how far we can go. Yeah, from here, right?